Hello everyone. Ignore these little icons here. This is a leftover from, ignore this too. This is a leftover sort of slide from when I used Pear Deck, but now I'm using this instead. So, we're talking about altruism this week. We've sort of already talked about it before with the selfish gene. So you can think of this as an extension of that, of the selfish gene. What altruism is, it's kindness found in nature. And when you talk about the selfish gene and kindness, how do you get kindness from a selfish thing? Well, that's what this is sort of all about. So this chapter, or section rather, we're talking about altruism, and I really think that this clip from Batman, The Dark Knight, with Heath Ledger as Joker, is a really great launching pad for this discussion. So we'll look at altruism from this movie and sort of analyze it from there.
Right? We should be on that pose. You want to ride across with them? Be my guest.
Alright, so basically there's two boats, and I can't tell from here, but let's just say that this boat here has criminals and this one has innocent people. So there's two different boats. You've got good guys and you've got bad guys. And so, whoops. You got good guys and you got bad guys. So let's see what the Joker does.
Sir, they've stopped their engines.
Right, get on the radio. Tell them we'll come back and pick them up once we dump the scumbags.
Liberty, this is Spirit. Come in.
What the heck is that?
Liberty, come in, please. Spirit, come in.
Fox, there's something going on the ferries.
Get down to the engine room now.
Captain, I got 100 barrels down there rigged to blow. In this.
Oh my God.
Looks like some kind of detonator.
Why would they give us the detonator to our own bomb?
Tonight, you're all going to be a part of a social experiment. Through the magic of diesel fuel and ammonium nitrate, I'm ready right now to blow you all sky high.
Liberty, come in, over. He's dead.
Anyone attempts to get off their boat, you all...
So notice one of the things that the Joker did was he stopped communication between the two boats. So there's two separate boats here. One has these innocent people on it, and the other has criminals on it. Neither boat can talk to each other. He's rigged them both with explosives.
I'm zeroing in.
Each of you has a remote to blow up the other boat.
Force is on the ferry, but it's not the source. West.
Gordon, I have the Joker's location. Pruitt Building. Assemble on the building opposite.
At midnight, I blow you all up. If, however, one of you presses the button, I'll let that boat live. So, who's it gonna be? Harvey Dent's most wanted scumbag collection, or the sweet and innocent civilians? You choose. Oh, and you might want to decide quickly, because the people on the other boat may not be quite so noble.
Okay, and so here we have the Joker's experiment. He has rigged both boats with explosives, and he's telling both boats that they have to pull the trigger to blow up the other boat. Otherwise, they will both be destroyed. So now, people on both boats are panicking. You have the criminals who are panicking and saying, press the button, I don't want to die. And you have the innocent people saying, press the button, I don't want to die. But watch what happens.
Stay back.
Well, now, who are you to decide? We ought to talk this over at least.
We don't all have to die. Those men had their chance.
We are not going to talk about this.
Why aren't we talking about it?
We're talking over the same exact thing on the other boat.
Let's put it to a vote.
Okay, so I guess the video I chose didn't go all the way through. You can see that there's a lot of mayhem and chaos in this scene. And, well, I hate to spoil it for you if you haven't seen the movie, but it's been out for a while now, so it's kind of your fault if you haven't. But basically, they both decide together that they're not going to blow up the other boat. The innocent people decide not to kill the criminals, and the criminals decide not to kill the innocents. And so Joker's experiment is sort of doesn't go the way he expected. He expected one of them to blow up the other boat. And so why didn't either side blow up the other boat? Why do people on the boat make the decision that they do? What motivates them? Is this an example of altruism? Why or why not? And can evolution explain the choices that were made here? And I think that by the end of this lecture, you should understand why they made that choice. I would like you to attempt to answer this. So on the next slide, there will be a question. If you could just try to answer these questions, basically, well, you could sum it up as one question. Why did both boats decide not to blow up each other? Why did the Joker's experiment fail? Keep in mind that when we talk in ecology about motives, we always try to look at it from the selfish gene. The selfish gene wishes to propagate and amplify at all costs. And so it kind of seems counterintuitive that doing something so selfless as dying, how could that be controlled by a selfish gene? So try to be creative, try to think of how that would actually help you with the selfish gene. Also, I think it's interesting to point out here the Joker's mindset. What is going on in his head? And how is that different than the Batman? The Joker basically believes that every single person on the planet is one bad day away from being evil. That we are all basically bad. Whereas Batman believes we are all basically good, but bad things happen to us. That is why the Batman refuses to kill people, for example. And so by the end of this experiment, I think perhaps we see the truth that maybe there is some good in us. I don't know, what do you think? Altruism refers to any behavior that is designed to increase another person's welfare, and particularly those actions that do not seem to provide a direct reward to that person who performs it. So for example, if I have 2 cheeseburgers and I have enough food for myself, I could definitely eat 2 cheeseburgers, but maybe one of my friends is hungry. So I give one of my 2 cheeseburgers to my friend. That cost me something. In nature, calories are extremely important. Calories increase fitness, the ability to survive and reproduce. Remember that in nature, we have a sort of currency. It's not money so much as it is fitness. Fitness is a spendable, savable, investable form of currency in nature. And so cheeseburgers would give me calories, and so calories would increase my fitness. So when I get rid of a cheeseburger and give it to my friend, I have just decreased my fitness. My friend, so this is me, my fitness goes down, my friend's fitness goes up. Yet, this is still the selfish gene. So how is it that the selfish gene would promote this behavior? Why would the selfish gene promote the behavior of giving up our fitness for other people? We see this type of altruism everywhere in nature. Seemingly kind acts that seem to decrease our own fitness for the sake of others. We see it everywhere. These chimpanzees are spending their valuable energy and attention and focus on grooming each other, helping each other, removing ticks and bugs. These parrots are doing the same thing, grooming each other, as well as these cheetahs. Even microscopic organisms, such as this slime mold right here, it also displays altruistic behavior, sometimes sacrificing themselves so that other slime molds can live. Why does that happen? We have a cheesy cartoon about a slime mold. So basically these two girls are looking under a microscope and they're looking at a slime mold. And they're talking about how they prey on bacteria in the soil and reproduce by cellular division, which we call binary fission. And so let's look at what happens as we go here. Okay, so she's saying when food is scarce, a unique strategy occurs. Basically, these tiny little spores or slime molds, this slime mold can form a multicellular structure where multiple slime molds come together, sort of like she's comparing it to Voltron. I think that's like a Power Ranger thing. I don't know. So here's what happens. Slime molds will grow and develop and divide when there's food, but when there's no food, they start to leave. They need to leave. And so what they want, what would be ideal, is to have a colony of spores that can be dispersed by the wind. But they need to get off the ground for that to happen. And so what happens is the slime molds that are here, they sacrifice themselves. They die. You get a column of dead slime molds. And so it's only the stuff at the top that will actually be dispersed. I like to think of this like, basically these things will grow on like a slice of bread. I like to think of it like this. Imagine that instead of a slice of bread, it's the earth. And instead of slime molds, it's our planet. Imagine that we use everything on our planet and the resources are gone. This would be like most of us sacrificing our lives so that a few of us could make it to another planet to continue our species. That is the same kind of thing that is happening here. Only a small group of these slime molds will actually make it to another food source. The rest will sacrifice themselves. So there are different types of this altruism, this kindness. The first one is called kin selection. Kin selection is when helping related family members increases your own fitness due to gene similarity. So that would be like me helping my brother because I share 50% of my DNA with him. Because I share so much DNA with him, helping him indirectly helps my selfish gene. Helping him indirectly helps my selfish gene. And that is because we share 50%. The selfish gene's whole motive is to amplify DNA. So if my DNA is the same or similar to those around me, then by helping them, I help that gene, just in a different meat suit. All right, reciprocal altruism is when you help those in need with the idea that they'll help you again in the future. You can think of reciprocal altruism as an insurance policy. In insurance policies, what we do is we pay a little bit per month towards our medical insurance or what have you, or car insurance, or whatever insurance it might be. It's not a big cost to us per month, but the reason we do it is because if we have some sort of emergency, we need to be able to fall back on that. And so fitness, we can use fitness the same way we use money, and we can invest it in a future. We can use it as insurance. And so by giving away a cheeseburger, I might lose a little bit of fitness, and my partner might gain it. But then in the future, those roles may be reversed. Perhaps one day I'll be hungry. Next, we have the handicap principle. So this basically says that by behaving altruistically, I display that I have an overabundance of fitness. I have so much that I can give things away. And that just makes me look more attractive. So it displays my superior genetics, and it increases my fitness because it makes me more attractive to the opposite sex. So for example, this would be like somebody burdening themselves with a charity. Say, for example, Bill Gates gives away 90% of his wealth, which he does, to charity, but he doesn't do it anonymously. He tells the whole world, everybody knows, it's well documented, he says it in interviews. So yes, on the outside, it would appear to be extremely altruistic, and thank God he does do that, because a lot of children would be dead without Bill Gates. But is he really doing it out of pure non-reciprocal altruism? Maybe, maybe not. The handicap principle is what he might be employing. We'll talk about that. So, and then finally, group selection is the only one of these here that I would actually disagree with, because it does not agree with the selfish gene. All of these here agree with the selfish gene. Their motives are basically selfish, but this last one does not. It is the misguided belief that individuals are altruistic for the good of the group. And that's just, I don't think, true. So we'll talk about why. Kin selection, just to go over it again, is this idea that we will help each other if we're more related. Take, for example, these meerkats. Here we have mom, and we have son, and we have daughter. Mom gives her DNA to her children. She gives 50% of herself to her children, and then the father would give the other 50%. It works out that these guys would be 50% related to each other as well. So between each other, they are also 50% related. You are 50% related. You have 50% of the DNA of your brother or sister, if they're your full brother or sister. If they're your twin, you have 100%, right? Okay, so mom helps the children because the children are amplifying her DNA. They're multiplying her DNA in the world, and that is the ultimate goal of the selfish gene. And so by performing altruistic things, by helping them at the expense of her own fitness, if she decreases her fitness but increases their fitness, she still gets a fitness amplification. And that is because at 50% plus 50%, these two together equal 100% of her. And actually, she'll probably try to have a third meerkat child to increase it to 150. That is why, for example, you find that most families like to have at least 3 kids, because at 3 kids, you would amplify your DNA. And so that is why parents are so willing to go out of their way for their children, is those children are an investment. Just like investments in real life, ecology is real life, but just like investments in economics, In ecology, when we decrease our fitness temporarily, we ultimately increase it later by having children. Now, this meerkat mother would help her children, but she'd be less likely to help her nephew or her niece, and that's because she is not as related. And so we can actually see in nature when organisms are more likely to help each other. You, for example, would probably be more likely to help your brother or sister than, say, your cousin. All right, I pulled this picture from a video I was watching. So let's talk about relatedness. You are 50% related. Actually, you know what? I'm going to start here. You are 50% related to your parents, but you are also 50% related to your siblings. And then you are 25% related to grandparents, and then 12.5% related to cousins. So let's look at that here. So you can kind of imagine it like a rainbow of relatedness right here. In the center here, we have your father, your mother, your sister, and your brother, and you're 50% related to them. Right? But actually, yeah, let's stick with percentages. Actually, that works. So 50% related to those most immediate members of your family, and you are most likely to be altruistic towards them. And then you have this outside layer here. This would be grandparents, uncles, and half-siblings. They are going to be 25% related to you. Then you go to cousins and great-grandparents, and that's going to be 12.5. Basically, we just keep cutting the amount of DNA that you share with them by half as we go outside this rainbow, right? And so this creates some very interesting altruistic kind of calculations. So we know that we're very likely to help people in the middle of this rainbow here. And so let's say, for example, that you, at the expense of your own life or whatever, you need to save members of your family from dying. Let's say that your brother is hanging off of a cliff, or sister, or whatever. Oh wow, my roommate's going crazy. So let's say that they're hanging off of a cliff, right? And you have to save them. And then your cousin is also hanging off the cliff. So there's your brother here and your brother is hanging off a cliff, and then your cousin is hanging off a cliff. You're most likely, according to the selfish gene theory, going to help your brother rather than your cousin. And that is because you share more DNA with your brother. But here's where it gets interesting. Let's say your brother's hanging off the cliff, but two of your cousins are hanging off the cliff. Will you save your two cousins, or will you save your brother? I don't know about you, but I'm going to save my brother. I'm sorry, cousins, but he's my brother, right? So my cousins are still going to die at that point. So let's look at why. So my brother, his name is George, he has 50% of my DNA. My cousins only have 12.5%. Even when there's two of them, that's only 25%. And so I still get more of a DNA amplification by helping my brother. So how many cousins is it going to take? Well, if it's between my brother and, say, 5 cousins, which is like all of my cousins, basically, my entire extended family, if my brother is hanging off of a cliff, and then, why am I drawing this? And then, why am I laughing? That's the bigger question. And then let's say that that my cousins are all trapped in a van and it's on fire. Wow, I might need therapy. Anyway, let's say that they're all hanging off of this one's hanging off a cliff and this van is on fire. Do I help my 5 cousins, or do I save my one brother? So my one brother is 50% related to me. My cousins are 12.5, but there's 5 of them. That makes 6.25. So at that point, according to the selfish gene, I would be more likely to help my 5 cousins and save them from my van with a heavy heart, right? But my brother would probably say, no, go, just go, help them, because he also knows. Anyway, another thing to consider, it's not just that. It's not just strict numbers. There's other things to consider too. Like, for example, if it's between my brother and all of my uncles and all of my aunts, so I have 4 uncles. Wait, I have a lot of uncles. Whoa, hold on. How many uncles do I have? 1, 2, 3, 4, and then 1 aunt, 5. Okay, so related to me, I have 5 uncles and aunts. 6 uncles and aunts. And so if I have 6 uncles and aunts and they're all in that van, but it's against my brother, so my brother's 50% related to me and they're 25%, the math would look like it would work out for me to save my uncles and aunts. But here's the thing, I'm still saving my brother. The reason for that, and I wouldn't even think about this, it would just be instinct. The reason for that is my uncles and aunts are done reproducing. They're not going to have more kids at this age. They no longer serve me toward genetic amplification. My DNA can no longer amplify them. But my brother, he is of reproductive age, and therefore instinctively I know to save him. You see? And this is another reason why we are so devoted to protecting the lives of youth, because they have reproductive capability and help our selfish gene. What I just said on the other slide was called Hamilton's fitness. Hamilton's fitness is this idea that we will do something that hurts us, a cost in fitness. We will accept that cost in fitness if the genetic relatedness of those we help times the benefit is greater than that cost. So if my genetic amplification is enough to withstand that cost, I will do it. And so benefit, when we say benefit right here, that means relative individual fitness. So take, for example, these honeybees, right? Actually, that's a really hard example. But these honeybees have a queen. Here's the queen right here. These honeybees will gladly lay down their lives to save the queen. And that is because these honeybees are sterile. They cannot reproduce. The only way they can get genetic amplification is by serving the queen. Every time the queen has a baby, these honeybees have indirectly increased their fitness. And so they will go to great lengths to do so. So their benefit is really high for their life being lost, whereas their cost is very low because they can't even reproduce. And so they're very likely to perform altruistic acts toward their queen. Their queen also makes clones. Every one of these honeybees is 100% related to each other. Whereas if they had children, they would only be 50% related to each other. They would only pass on 50% of their DNA. The queen makes all of these the same. And so actually by helping the queen, they get a greater fitness advantage than by having their own children. And so that is another reason why they will go to such great lengths. So the last form of altruism we talked about was kin selection, where we are more likely to perform altruism towards those we're related to. This one is about reciprocity. So what do I get in exchange? Rather than genetic amplification, what immediate fitness can I get that helps me in my survival? And so the first one would be reciprocal altruism through reciprocity. So reciprocity basically means, and all of these are reciprocity, but direct reciprocity is when you get something in return, like I scratch your back, you scratch mine. So for example, this hungry bat, it's a vampire bat, is getting food from this satiated bat, which means well-fed bat. What this means is, they're swapping blood because they're vampire bats. This means that this bat is losing fitness, it is losing calories, whereas this one is gaining it. And so the reason why this bat, the satiated bat, would do this, would voluntarily decrease its fitness, is because one day these roles might be reversed. It is an insurance policy. Just like insurance, I am putting some money down now so that in the future if something bad happens, I'm safe. And so that is what reciprocal altruism is all about. Now sometimes this is direct, like you can see with this hungry bat, but sometimes it is indirect. So indirect reciprocity is basically establishing a reputation. And these bats are actually, I do believe that this bat is an example of indirect reciprocity, because chances are that these two don't really remember each other or can't really find each other in the cave. But by getting a reputation as being a feeder, you are more likely to be fed. You can see this same sort of thing like in chimpanzees when they groom each other. They're getting a reputation for being a good groomer, and so they get groomed in return. Reputation is very important in human culture too, human ecology. Establishing a good reputation as a good worker is likely to get you like a promotion. Next we have pseudo reciprocity, which is when you do something for someone, you give something to someone with never the intention of receiving anything. In fact, you never do directly receive anything for it. But you're doing it so that that person or animal or plant, whatever, will do something in the future that benefits you. You're trying to direct their actions. So say, for example, you are the U.S. government and you're the CIA, and let's say that, I don't know, Cuba has a dictator that we want to be removed, and so we just give the rebels a whole bunch of weapons. That is our gift to the rebels, right? And we don't expect anything for it. We don't want anything for it. Hey, just have these weapons. Just take them because we're nice people, right? But well, no, that's just the CIA wanting the rebels to overthrow the dictator because they don't like the dictator. Now, this actually happened. Look up Bay of Pigs. It was pretty awful. Did not go so well. Anyway, that would be pseudo-reciprocity. And so all of these are just, I scratch your back, whether directly or not directly, you scratch mine. All right, so why did the people on the boat make the decision that they made? Well, what motivated them? It might be reputation. So if you are a family member and you have, even if you have family members on board, you might be tempted to blow up the criminals because you want to save your family. But then there's this thing called shame. And shame is extremely, extremely important. There's a reason why we experience shame. When we experience shame, it is our brains acknowledging that we have had a fitness reduction. Those around us have judged us, or we're judging ourselves. We're holding ourselves to a standard. Our selfish gene holds our behaviors to a standard because it knows that when we don't behave to that standard, society will judge us and our families. And so you can see in a lot of Japanese cultures, for example, they're very big on shame. There's ritualized suicide, for example, when members of a family dishonor the family. The only way to regain that honor is seppuku, ritualistic suicide. They go to extreme lengths to regain a family's honor. Honor is everything. Shame is really awful in societies like that. And in every society, we try to preserve ourselves from shame. So shame is like a natural barometer that the brain uses to judge how how well we have managed to invest our fitness in the future by people's judgment of us. And so perhaps they were hesitant to press the button because they didn't want the shame, and they didn't want the shame brought to their family and their extended family, and they didn't want to reduce the potential of genetic amplification in that way. And you see, that sounds ridiculous, right? Because if you have your family member on the boat with you, then why would sacrificing yourself help you? Wouldn't shame be better than losing like a child or losing yourself? Well, that is because we evolved in the past. And in the past, in those tight, small groups, reputation, shame, family honor were the most important thing. The most important thing in societies. There was nothing more important than family honor and shame. If you've dishonored your family, if your family is dishonored, you decimate their ability to survive and reproduce in small groups. We are still set up. We are still evolved from that time. The selfish gene may be a puppet master, pulling our strings of emotion and pulling our strings, making us perform certain acts of kindness, but a lot of those strings are being pulled from a different time. And we're not the same creature anymore. We're not living in the same time. And this has created really novel behaviors that don't necessarily just promote our own survival and reproduction. They have become new and unique and vestigial. Vestigial means an evolutionary leftover. And so that is most likely why these people on this boat did not pull, on either boat, did not pull that lever. They did not pull the lever because of the vestigial, the vestigial selfish gene actions that are still firing within our genes. So is this an example of altruism? Absolutely. So yes, both sides are being very altruistic, sacrificing their own lives and those that they love for an ideal that brings them honor and saves them from shame. And can evolution explain these choices? Yes. As I just said, we evolved to resist shame, resist dishonoring our family. We have evolved to honor our families, create good reputations, invest our fitness in others. And it is such a strong evolutionary force that is so ingrained in us from a time of being small groups that it has become a huge part of us. And so I like to conclude this by saying that yes, our actions might be rooted in the selfish gene, but those roots have grown into something else. We are not just the selfish gene. I believe that selfish gene might be the roots, but what has grown from it is very beautiful. And I think that altruism, in its truest form, altruism without the anticipation of any reciprocation, this means anonymous donation, that in its truest sense is what it means to be human and what separates us from beast. Group selection is this idea that we will sacrifice ourselves for the greater good. We will perform altruism because deep down inside we are good. That goes against the selfish gene hypothesis, though. And so most scientists disagree with group selection. It is a misguided belief, an old idea, really. And so this clip right here from 1998's movie Armageddon with Bruce Willis and Scott Adkins, I believe, is the other actor. It really shows this dilemma, this debate between group selection and the selfish gene acting. And so try to watch this clip, and I'll try to dissect it with you, and we'll see what's really going on. So here's the two actors right here. We've got Bruce Willis on the left, and we have Scott Adkins on the right. So this guy is the husband of this man's daughter. And so what's happening here is they're going in this little capsule. There's an asteroid, and it was about to hit the Earth, and so NASA sent up these guys and their team to put an explosive on the asteroid to change its trajectory. And they thought they could save Earth that way. But everything goes wrong. Nothing goes the way it should. And in the end, they have to detonate this by hand. And so these two men are going to their death, knowingly going to their death, to blow up the asteroid by hand for the greater good or whatever. So let's watch that. As we build to this moment, you can kind of see it in their face, this sense of pride. And so what is pride, and what is its opposite? Shame. Pride is the brain telling you that you are doing something which will give you a good reputation. You are doing something that you are proud of, that others will be proud of, and that is basically a barometer for how likely, an internal barometer that you have for how likely the rest of the world is to treat you. And so they are feeling a great sense of pride as they do this, of duty. And that is an advantage to their family. When the world hears about what these two men are doing, their family will be treated extremely well and do extremely well. And that is the selfish gene.
Do me a favor, will you? Just tell Grace that I'll always be with her, okay?
Grace is this guy's fiance or wife and this guy's daughter.
Can you do that?
Yeah. Okay, kid.
Mr. Truman. Make sure Truman gets that. Get in.
It's my turn now.
Harry! Harry! You can't do this to me! It's my job! You go take care of my little girl now. That's your...
He said, "It's my job." You see, there's that duty. He feels duty bound. Duty and honor very much promote the selfish gene. It establishes a reputation for your family and increases the chance of genetic amplification. And then you hear Bruce Willis say, "No, you take care of my little girl. That is your job. That is your duty." And so Bruce Willis is saying, yes, duty is important and I will do it. But I really need you to watch after my granddaughter, to amplify my genes. That is the selfish gene.
Always thought of you as a son. Always.
I'd be damn proud to have you marry Grace.
Bruce Willis recognizes that this man is a good genetic match for his wife. You see, in reproduction, we only pass on 50% of our genes. That is the cost of sex. In sex, we mix DNA. The benefit is that we get a mix. If we are to sacrifice 50% of our genetic amplification for sexual reproduction, the benefit should outweigh that cost. In this particular instance, Bruce Willis recognizes that the benefit of this man's superior genes outweighs that loss. And so he is extremely driven to protect this man because he recognizes his genetic quality and how well he can help his offspring.
You take care of yourself.
And so basically, yeah, he ends up blowing himself up and saving the Earth. And in the end of the movie, that you can actually see that his family gets rewarded for this. And so, yes, it does end up helping his family. And that is why honor and duty are such a powerful driving force for our human behavior. And why shame is so avoided. If Bruce Willis had not done this, but the son had instead, then that would have been shameful. Bringing shame to your family is not as bad today as it used to be. We sort of see people as individuals now because we have such big societies. But bringing shame to your family back at the inception of human evolution, when we were small groups, was detrimental to your family. If you shamed your family was likely to be shunned and not survive. And so we have ingrained in our DNA the extreme avoidance of shame and the extreme attraction to duty and honor.